Hi, in this video we'll learn kinematics. So we'll learn kinematics from very basics to very advanced stuff. We'll look for tricks, shortcuts that will save your time while solving the numericals. So hi, my name is Ashutosh. 2 to 3 things that I want to specify before you start watching this video. There is only one prerequisite for watching this video. That is, you have to know basic concept of differentiation and integration. That is differentiation and integration of x raised to n. So this video is for someone who is starting, who is at very early stage and who wants to understand kinematics. They can watch this video. This video is also for someone who has little knowledge about kinematics and want to explore more or want to learn this chapter in depth, and NEET is looking for some shortcut tricks that will save his time. But for such students, I'll suggest bear with us for 5 to 10 minutes as we'll touch on the basics that you may feel that you know, but yeah, do bear with that 5 to 10 minutes, and then we'll jump into advanced stuff, so you'll love it very much. So let's start. So let's go from very basics. So in kinematics, let's say let's first define what is distance. So the question is, what is distance? So the simple answer to this is distance. I can call it as simply path length. In simple terms, I can call it as path length. The second definition which you will want to know is displacement. So the basic definition of displacement, I can write it as shortest path. I'll term it as shortest path. Term is at shortest path. So let's consider an example here itself. Suppose this is my point A and this is my point B. So suppose I want to go from point A to point B. So I started walking this way, then I took a right turn, and then I walked straight to the point B. Now for my distance, the length of this path will be my distance, that is this plus this length plus this length. For displacement, it will be the shortest path. So shortest path is always a straight line joining the 2 points. So this will be my shortest path. So this is my displacement. So this path length is my distance and the shortest path is my displacement. Okay, let's move on to next definitions. So your next thing that you want to know is speed. So what is speed? Speed is simply, I'll say, distance per unit time. So I can write speed as distance divided upon time. I will write speed as distance divided by time. Now there is one more term that you want to consider, that is velocity. So now what is velocity? Velocity is simply displacement per unit time. So I'll write velocity as displacement divided by time. So let's again take this example itself. So suppose I take let's say 10 seconds. Let's say 10 seconds to grow from point A to point B. So my speed will be this path length divided by 10. That would be my speed. And for my velocity will be this displacement, that is the shortest path, divided by 10 seconds. So that will be my velocity. Now moving on to last definition. The last definition is something we called as acceleration. Now what is the definition of acceleration? In simple terms, acceleration is rate of change of velocity. So it means by what rate is your velocity changing, that is defined as your acceleration. So in this case, I am considering that I am moving with constant velocity, that my velocity is not changing. So if my velocity is not changing, there is no rate of change of velocity. So therefore, since the velocity is constant, therefore my acceleration will be 0. So I will define acceleration as rate of change of velocity. We'll define acceleration as rate of change of velocity. So let's do few sums on this. Now these are some good sums, you will like the sums. So moving on, let's move to our first sum. So again we'll just recap all this. Your distance is your path length, displacement is the shortest path, speed is defined as distance per unit time, velocity is displacement per unit time, acceleration is rate of change of velocity. Let's move on to sums. So your first sum is, consider this triangular path. Suppose this is point A, this is point B, and this is point C. So this is a triangular path, point A, point B, and point C. So the question is, I start from point A. So I started from point A. I moved from point A to point B with velocity 10 meter per second. I moved from point A to point B with velocity 10 meter per second. Then I moved from point B to point C with velocity 20 meter per second. Later, I moved from point C again to point A with velocity 30 meter per second. Now there is one more information given to you. Triangle ABC is an equilateral triangle and length of the sides is 60 meters. That means each side is of 60 meters. So I'll again repeat the question. The question is, there is a triangular path ABC. So I started moving from point A with velocity 10 meter per second. I maintain this velocity till I reach point B. Then I switch to velocity 20 meter per second till I reach point C, and finally my velocity becomes 30 meter per second when I again reach point A. So question is, so you have to find from A, that is, if I start from point A to point B, point C, and again point A. So in this journey you have to find me, first thing is you have to find time. So you have to find time taken from point A to point B, then point A to point C, then point A to point A again. So first thing is point. Second is you have to find me distance from point A to point B, then point A to point C, then point A to again point A. So you have to find me total distance from between these two, and you have to fill it in this columns. Next you have to find me displacement. That is displacement from point A to point B, displacement from point A to point C, displacement from point A to point A to point A, and then you have to find me average speed. You have to find me average speed from point A to point B, then point A to point C you will write here, point A to point A you will write here, and lastly you need to find me average velocity from point A to point from point A to point B, then point A to point C, and then again from point A to point A. So take 2 minutes of your time, solve this. If you are unable to solve, if you have any doubts, just look for solution. So take your 2 minutes time and give it a try. And stop. So your 2 minutes are done. So if you want more time, you can pause the video and complete your sums, and then you can look for the solution. So I'll start with the solution. So first thing they have asked me is, they have asked me time. So from point A to point B, I have information that this length is 60. Now length is 60, that means the path length from point A to B is 60. That means I know distance is how much? 60. So from point A to point B, my distance will be 60. Then from point A to point C, suppose I move from A to C, then my path length will be this 60 plus this 60, so it will be 120. So my distance is again 120. Then from A to A, my distance will be 60 plus 60 plus 60, so it will be 180. Now for time, I know my time is your speed upon your distance upon speed. So my distance for A to B is 60 divided by speed is 10. So my time will be 6 seconds. right? My time will be 6 seconds. Now from point A to C I have to add time of A to B, then again B to C. So A to B is, I got it as 6 seconds. Then from B to C it will be 60 upon 20, 60 upon 20, that will be 3 seconds. So for A to C my total time will be 6 plus 3, that will be 9 seconds. And lastly I have to find time taken for man to move from A to B, then B to C, and then C to A. So I'll calculate time from C to A. So time from C to A will be 60 divided by 30, that will be 2 seconds. So my total time will be 6 plus 3 plus 2, that goes to 6 plus 3 is 9, and then 9 plus 2 is 11 seconds. Nine plus 2 is 11 seconds. So I got my time. So from A to B my time is 10 seconds, then my A to C my time is 9 seconds, and then again A to A my time is 11 seconds. I have also got the distance. Now let's move on to displacement. As we know, displacement is the shortest path. So from A to B my shortest path is simply the straight line joining it, and the straight line joining is again 60. So my displacement will also be 60. From A to C my distance was 120, but my displacement will be the shortest path. So this is my point A and this is my point C. So I'll just simply join the line. If I join the line, the distance comes out to be 60 meters. So from A to C my displacement will be again 60. And lastly from A to A, so I have not moved, I mean I am going from point A to and coming back to again point A. So the shortest distance is 0, as there is no resultant change in the distance. So my displacement from point A to point A will be 0. Now we'll calculate average speed and average velocity. Now average speed by definition, it is total distance upon total time. So for this it will be 60 upon 6, that will be 10. So my average speed is how much? 10. In this case it will be 120 upon 9. So 120 divided by 9. I'll not simplify it, I'll just keep it as it is. It will be 120 upon 9. You can write 40 by 3 and whatever, but I will write it as 120 by 9. Then last for A to A my average speed will be 180 by 11. Average speed will be 180 by 11. Last part, average velocity. Average velocity is total displacement upon total time. So total displacement 60 divided by time 6, so it will go 10. So my average velocity from A to B is 10. Then average velocity from A to C will be 60 divided by 9. It will be 60 divided by 9. And lastly it will be 0 divided by 11, that accounts to 0. So this completes your first sums. So if you have any doubt in this, you can comment in the comment box below, or you can reach out to me on my social media platforms. The description is in the links. So feel free to reach out if you have any query or any doubt. Okay, so now we'll move on to next question. We'll do a similar type of the question, just little twist in that. So now the question is, consider a circular path. So this is a circular path. This is a circular path. This is your point A, this is your point B, this is your point C, this is your point D. Now all the points are at the quarter end point. That means the angle between this both lines is 90 degree. So this is here, the angle between A and B is 90 degree. And the radius of the circle is given to you as 100 upon pi. So the radius of the circle is given to us as 100 upon pi. Now the question says a man start moving with speed 10 meter per second. Start moving with 10 meter per second from A to B, then B to C, and then C to D, and again D to A. Now the question also says the speed is along the circle. That means at every point the tangential velocity will be 10. So at B this speed will be 10 meter per second. Here it will be 10 meter per second. Again here it will be 10 meter per second. So the speed is along the circle 10 meter per second. That means at any point the tangential speed will be 10 meter per second. So now question to us is, the question is, it is similar. So you have to find from A, to here there are four points. So we'll find from A to B, then you have to find from A to C, then A to D, and then again last A to A. You have to find time. Then you have to find distance, then you have to find displacement, you have to find average speed, and lastly you have to find average velocity. Okay, so from A to B you have to find time, your distance, displacement, average speed, average velocity. Similarly you have to find from A to C, then A to D, and then A to A. So take 2 minutes of your time and give it a try. So your 2 minutes starts now. So your 2 minutes are done. If you feel you want more time, pause this video, take your time, and then come and have a look at the solution. So we'll start with the solution. So to start the solution, I'll see I am starting from point A. My velocity, my speed along the circle is 10 meter per second. So first I will go from point A to point B. So first let's calculate the distance from point A to point B, then point A to point C to point A, then point D to point D to point A. So now we know from A to B it is a quarter circle. So for distance I need to find this circumference, that is quarter circumference. So my radius is 100 upon pi. The circumference of complete circle will be 2 pi r. So I'll multiply 2 pi by this r. So pi and pi will cancel out. So my total circumference is 200. So from A to B it is 1/4. So distance from A to B will be 50. Distance from A to C will be 100. Distance from A to B will be 150. Since it will be 3 quarter circles, and then distance from A to A will be 200. Now you have to find time. Now since the distance speed along the circle is 10, so therefore I'll divide this distance upon time. So from A to B the time will be 5 seconds. From A to C the time will be 100 upon 10, that will be 10 seconds. From A to D it will be 15 seconds. From A to A it will be 20 seconds. Now you have to find displacement. So displacement is the shortest path. So this is my point A, this is my point B, and this was my distance. For displacement I'll join point A and point B. So this is my shortest path and this is my displacement. I know radius is 50, so this will be 50 and this will be 50. This is a right angle triangle, so this will be the hypotenuse of this right angle triangle. Since it is the hypotenuse of the right angle triangle, the length of the hypotenuse will be root 2 into 50. Again I have used Pythagoras theorem. Root of side 1 square plus side 2 square is equal to hypotenuse square. You can simplify and you will get the same answer. So my displacement from point A to point B is, it will be root 2 times 50. Now my displacement from point A to point C. So this is my point A and this is my point C. If I join a straight line, it will be this radius 50 plus this radius 50. So my displacement from point A to point C is 100. So my displacement from point A to point D will again be this line. So it will again be root 2 into 50. And finally displacement from A to A will be 0, as we have come to the same point. Now last two parts is you have to find average speed. So average speed is distance upon time, so that will be 50 upon 5. It will be 100 upon 10. it will be 150 upon 15. It will be 200 upon 20. Finally moving to average velocity. So average velocity is your displacement upon time. So your displacement from A to B is root 2 into 50. I'll divide this by time, that is 5. Second, it is 100. 100 divided by 10. Okay, we have done a mistake in this part. So the displacement from point A to point B will be 2 times the radius. Since our radius is 100 by pi, so our distance will be 2 times radius. That will be 200 upon pi. I thought the radius was 50. No, the quarter circumference was 50. So here we know that radius is 100 upon pi. So the displacement from A to C will be 2 times radius. So that goes to 2 multiplied by radius, that is 200 upon pi. So my displacement from A to C will be 200 upon pi. So average velocity will be 200 divided by pi and then divided by 10. So it will be 200 upon 10 pi. Then from A to D it will be root 2 into 50 upon 15. And lastly it will be 0 divided by 20, that goes to 0. So this complete our sum. If you have any doubt, you can comment below or reach out to me on my social media handles. Now we understood the basic, what is distance, displacement, your speed, velocity and acceleration. Now we'll move on to motion. So before moving on to motion, let's understand some of the terms that we need to be familiar that are commonly used in kinematics. So your displacement is always represented by S, or we call it x. Then your velocity is represented by v, your acceleration is represented by a. So your displacement is x, your velocity is v. I can also write velocity as dx by dt. What is dx by dt? Is a small distance upon small time. So therefore this is a differential form. I can write velocity in, that is dx by dt. My acceleration will be I can double differentiate. If I differentiate displacement, it gives me velocity, that is dx by dt. If I again differentiate the displacement, it will give me acceleration. So my acceleration will be d2x by dt square. d2x by dt square, or I can write my acceleration as dv by dt. So you have to remember this. Your displacement is x, velocity I can write it as dx by dt, acceleration I can write it as dv by dt. There is one more term which I can write acceleration as, so I'll derive it for you. As I can write acceleration as dv by dt, what I will do is I'll multiply this term by dx. So I'm multiplying this term by dx and then again divide this term by dx. So basically I have multiplied this term by 1, as dx by upon dx is 1. So now I want to look closely to this. So this gives me dx by dt, and I can write dx by dt as v. So you can also write acceleration as v dv by dx. So do remember this part, the acceleration as v dv by dx and acceleration as dv by dt. This will be used in some of the integration or differentiation sums where we want results in velocity and displacement, and we don't want the result in time. So for now just remember this. So I'll also tell you one thing, so suppose if this is your displacement, this is your velocity and this is your acceleration. So if information of displacement is given to you and velocity asked, that means you have to move down. So for moving down you need to differentiate. That means you will differentiate displacement, that is dx by dt, to get your velocity. So if velocity is known and you want acceleration, again you will differentiate. So for moving down you need to differentiate. Velocity will be dx by dt. So here I differentiated my displacement. Your acceleration will be dv by dt. So here I differentiated your velocity. Now if you want to move upwards, that means if information of acceleration is given to you and velocity is asked, for that you need to integrate it. So for going from A to B, I'll write velocity as, I can also write velocity as a dt. So in this, if information of acceleration is given to you, I can write velocity as integral a dt. This is integral sign. This is indefinite integral. Therefore, I have not put the limits. If the limits are given to you, you can put the limits and then solve the sum. So how this accounts to v? Let's see it here. So I can write it as a dt. Now what I can write acceleration as? I can write acceleration as dv by dt. So I'll write my acceleration as dv by dt. So it will become integral dv by dt multiplied by dt. So my dt term will cancel out. It will be dv. So integral dv is v. Therefore, I can write v as integral a dt. So if information of acceleration is given, you can use this to get the value of velocity. This is velocity equal to. Similarly, your displacement will be equal to integral v dt. Again, same thing, you can write v as dx by dt. dt will cancel out. You are left with integral dx, and integral dx will again give you x. So if you have to go down, you have to differentiate. If you have to go up, you need to integrate. You can remember in this way. If you have difficulties in remembering this, over a period of time you will remember this. So let's start with motion. So in kinematics, you will have 4 variables, that is your initial velocity, your final velocity, your displacement, and then last is your time. And then acceleration is also there. So these are some of the terms which will be used in kinematics. So this will use in motion, therefore I am giving it here. So in motion, there are broadly all motions are classified into 2 types, uniform motion and non-uniform motion. So one is your uniform motion and second is your non-uniform motion. First part is your uniform motion, second part is your non-uniform motion. So in uniform motion, what uniform motion means, that your body is moving uniformly. That means it has a constant velocity. So if it has constant velocity, there is no change in velocity. That means acceleration will be 0. So anytime if you want to identify which type of motion is it, first look at the acceleration. If acceleration is 0, that is your uniform motion, and your velocity will be constant. Here my velocity will be constant. Since my velocity is constant, I can write v as, I'll write v as dx upon dt. I'll write vx as dx by dt. Now dx by dt is equal to v. I know this. I'll move this dx to this side. So I'll left with dx is equal to v dt. Then I'll integrate both the sides. So if I integrate both the sides, integral dx is x. Since my velocity is constant, v will jump out of integration and I'll left with only dt. So integral dt will give me t. So from here I get x is equal to vt, that is displacement is equal to velocity into time. So this is the integral derivation of the formula. Now moving on to next type of, so in uniform motion you will have only one formula, that is displacement is equal to velocity in time. I will move on to non-uniform motion. In non-uniform motion, you have 2 types. One is uniform accelerated motion. The vehicle is accelerating uniformly, that means acceleration is constant. Second is non-uniform acceleration. So let's start with uniform accelerated motion. We'll start with uniform acceleration motion, uniform accelerated motion. So in uniform accelerated motion, your acceleration will be constant. So if you find acceleration is constant, that motion will be your uniform motion. Now since acceleration is constant, we'll try to derive same results for uniform acceleration motions. So if acceleration is constant, I can write acceleration as dv by dt. acceleration I can write as dv by dt. So I'll write dv by dt is equal to a. I'll take dt at this side, so I'll left with dv is equal to a dt. So I'm left with dv is equal to a dt. Then I'll integrate on both sides, integral v. Now in this it is integral dv. So I'll put the limits in this. So I will integrate from u is my initial velocity and v is my final velocity. So at initial my time will be 0, and at any time t let my velocity be v. So yeah, I substituted the limits. So limits is initial u to v, that is initial velocity to final velocity. Time is from 0 to t. Now since acceleration is constant, a will jump out of the integral. So integral dv will be v, and then you have to substitute the limits. So the limit is from u to v. So when you substitute limit in integration, it is upper limit minus lower limit, and then this will be equal to a into t. Here again we have limits from 0 to t. Again it will be upper limit minus lower limit. So in this case, upper limit minus lower limit will give me v minus u is equal to, here upper limit minus lower limit will be t minus 0, so that will be t. So it will be at. So from here you get your first equation of kinematics, that is v is equal to u plus at. So this was the derivation of your first equation of kinematics, v is equal to u plus at. For second equation, I told you we have one more term to describe a, that is I can also write acceleration as v dv upon dx. So if I can write v dv by dx is equal to a, I'll take dx term at this side, so I'll left with v dv is equal to a dx, and then I'll integrate on both sides. So I'm left with u, velocity limits I'll put from u to v, and displacement limit I'll put from 0 to x. So since acceleration is constant, this will jump out of integration. So integration of v dv will be v square by 2. I have to substitute the limits, that is from u to v, and here it will be, since a is out of integral, it will be a, and integral dx is x. It will be from 0 to x. So if I simplify, this will be upper limit minus lower limit. So therefore v square by 2 minus u square by 2. So it will be v square by 2 minus u square by 2, and this will be equal to ax. So here you get your second equation of kinematics. So your second equation of kinematics is v square is equal to u square plus 2a s. S and x is same term. It represent displacement. So these are the only two terms that you get from derivation. The third term is you get from simultaneously solving this. So I'll give you two more terms to remember. So these are the two terms. So I'll give you two more terms so that you can solve sums faster. Equations to remember in uniform accelerated motions are, first is v is equal to u plus at. V is equal to u plus at. Second equation is s is equal to ut plus half a t square. Your third term, now mostly people use three equations, so I'll give you two more equations. So this third equation is s is equal to vt minus half a t square. So what this does is, if information of final velocity is given to you, you don't have to simultaneously solve this. You can directly use this equation, that is s is equal to vt minus half a t square. Now your fourth equation is v square is equal to u square plus 2s, and then your final equation, which I recommend to remember, is s is equal to v plus u by 2 into t. So if possible, do remember this all 5 terms. Now after this, I'll give you a trick also, that if you remember the trick, if you get the trick, you don't have to remember this, and it will be very easy for you if you follow the trick. So that is coming after this. So for this 5 equations, again there is sign convention that you have to follow, that you can take any one side as positive. So if you take this side as positive, this side will be negative, and then upwards as positive and downwards as negative. You can take any one side as positive and any other side as negative. But if you are just starting to solve the sums, I'll suggest go with the x-axis and y-axis term. So the right side is positive, upwards is positive, downwards is negative, left side is also negative. So if your acceleration is, let's say, gravity, so gravity is always acts downwards, so you will take a gravity as negative. These are the few equations that I recommend you should remember, so get your solving faster. Now moving back to this, we have concluded your uniform motion. So uniform motion's acceleration is 0, velocity is constant. Then we have got one formula for that, that is displacement is equal to velocity in time. So we have only one formula for uniform motion. Then we move on to non-uniform motion. In non-uniform motion, you have done our first type, that is uniform acceleration motion. So in uniform accelerated motion, we got derivation of two equations, that is v is equal to u plus at and v square is equal to u square plus 2s. Now simultaneously solving these terms, you get your rest of your equations, that is v is equal to u plus at, s is equal to ut plus half at square, s is equal to vt minus half at square, v is your final velocity, v square is equal to u square plus 2s, s is equal to v plus u into t. So now we are done with two types of motion. One is uniform motion, second is uniform accelerated motion. Now we'll move on to third and the last part, that is non-uniform accelerated motion. So for syllabus of JEE and NEET, there are only 3 types of non-uniform motions that they can ask you. So there are only 3 types. The 3 types are, they will give you acceleration as a function of time. So they will give you acceleration as a function of time, or they can give you acceleration as a function of velocity. They'll give you acceleration as a function of velocity, or they can give you acceleration as a function of displacement. So what do you mean by function of time, function of velocity, function of displacement? Is they can give you acceleration is equal to 3t square minus t. 3t square minus t. So 3t square minus t is a function of time. So they can give you in any functions. So I am writing in a general term. So let's look for first term, that is acceleration as a function of time. So if they have given you this term, what we'll do is we can write acceleration as dv by dt. We can write acceleration as dv by dt, and it will equate to function of time. And what I'll do, since dt is here and here function of t is there, I'll take dt at this side. So what I'll do, I'll write dv is equal to f of t dt, and I can integrate f of t as it is a function of time and the dt is also present here. So I'll integrate both sides and I will get my answer. So in this case, I can integrate 3t minus t, that will be 3t square by 3 minus t square by 2. It will give you answer. Again, you need to know integration basics to solve this. So this is pretty easy. Just remember the results, not need to remember the results, just you need to know how to go about this. So any sum will not be new for you. Second, if it is given acceleration as function of displacement, I can write acceleration as v dv by dx. I can write acceleration as v dv by dx. So v dv by dx is equal to f of x. Since f of x is present at right side, I'll take dx over there. So I'll do v dv is equal to f of x dx. I'll do v dv is equal to f of x dx. So integral v dv is equal to integral f of x dx. Again, you will get your answer. Now moving on to last, acceleration as a function of time. Here you can use both the terms. So I'll do first acceleration as dv by dt. Since acceleration is dv by dt, I'll write acceleration as dv by dt is equal to f of v. Now at right hand side I have f of v. I can't take dt over here because this will not integrate. Function of velocity cannot be integrated with dt term. What I can do is I can take f of v to the left side. So my term will be dv upon f of v. Now this we can integrate. dv upon f of v is equal to dt, and then I'll integrate on both the sides. I'll get the equation in terms of velocity and time, and I'll get my solution. I can also write it as v dv by dx. I can also write it as v dv by dx is equal to f of v. Same thing, I'll take f of v to the left side and dx to the right side. So I'll left with v dv upon f of v is equal to dx, and then I'll integrate both sides. I'll get my answer. So in this we have covered all types of motions that can from where the questions can be asked. So in motion, let's go back and revise our thing. So in motion, first type of motion was uniform motion. In uniform, first thing you have to identify the motion. It is easy to identify the motion if you look at the acceleration. First look whether it is 0. If it is 0, it is uniform motion. Then if it is constant, then it is non-uniform motion. If it is neither, it is variable. Then it is your last part, that is your non-uniform motion, non-uniform accelerated motion. So in uniform motion, acceleration is 0, velocity is constant. We have one formula, x is equal to vt. In uniform acceleration term, we have 5 equations that we have already done. And in last part, non-uniform accelerated motion, they can ask you, they can give you acceleration as a function of time, acceleration as a function of velocity, and acceleration as a function of displacement. So this covers a broad view of your motion. So now let's get started in some of the sums. So we'll do first sums in equations form. So if I give you if displacement is given as a function of time, so let's say if I give you x is equal to 3t square, x is equal to 3t square minus 6t, and you're asked find velocity at t is equal to 2 seconds. You have asked find velocity at 2 is equal to 2 seconds. So take your 2 minutes time and solve this. And stop. So in this, let's see the solution. So it is given that displacement as a function of time is given to you. So displacement is given and I asked about velocity. That means I have to move from displacement to velocity. So if I have to move down, I have to differentiate. So what I'll do, I can write velocity as dx by dt. I'll write velocity as dx by dt. So I'll differentiate this. So it will be d of 3t square minus 60, d of 3t square minus 60 divided by your dt. So if you differentiate 3t square, you will get velocity as 60 minus 6. So and when you substitute t is equal to 2, your velocity will be 6 2s are 12 minus 6. So your velocity will be 6. Now this was a pretty simple question. Let's move on to one more question. So the equation is your velocity is given as 3t square plus 4t, and you have asked displacement at t is equal to 1 second. You asked displacement as t is equal to 1 second. Now one more information is given to you. At t is equal to 0, displacement is 0. And one information is given to you. At t is equal to 0, your displacement is 0. So take your 2 minutes and solve. And stop. So in this question we were asked to find displacement, and information of velocity is given to us. That means we have to move up. So I can write displacement as integral v dt. I can write this. Then I'll substitute the value of v. So it will be integral v is 3t square plus 4t, and then dt. If I integrate this, I will be left with 3t cubed by 3 plus 4t square by 2 plus 4t square by 2 plus one constant term. See, because if you are doing indefinite integral, you have to add a constant. So this final equation will be t cube plus 2t square plus c. Now to find the value of c, one information is given to you. At t is equal to 0, x is equal to 0. So if I write my equation, x is equal to t cube plus 2t square plus c. So if I put x as 0, the RHS should be 0. That means c should be equal to 0. Now we have asked displacement at t is equal to 1. So I'll substitute the value of t. So it will be 1 plus 2. So my displacement is 3.